the next one asked you to create a function parameterized by a type t. So in other words, it can operate on streams of different types, which given to infinite streams. And this was something I didn't originally sort of emphasize, but it makes it easy and allows you to focus in on the key components. Returns a stream whose successive elements alternate are drawn. Alternatively, are drawn from successive elements of A and B. So the first element of the stream returned will give A, the first element of A. The next element returned by this in the stream returned by the function will be the first element of B. The next one will be the second element of A. The next one will be the second element of B. Third element of A. Third element of B. Yeah.
So it's not fourth. The last fourth. It's going to be second.
Sorry.
Last line.
Last line.
Be the fourth. It's going to be second. The second element.
Correct. Yes, that's correct. Yes, thank you. I'll have to correct that. So okay. So how do we define that? How could we define that? Anyone? Let's define a function. Okay, good start. Not to be minimized. Okay. So I'll call alternating stream one. Okay, T. Okay, here's our type. So this can be applied to streams of strings, or it can be applied to strings of ints, or strings of longs, or strings of doubles, streams of longs, doubles, ints, etc. And as long as both streams are the same type T, of the same type. Okay, cool. So what is it going to take as its two arguments? Well, it pretty much tells it two streams, yeah, given two infinite streams. Okay, so we're going to have a stream. Maybe I'll call, this will be a particularly transparent one. I'll call stream even and stream odd. Okay, stream of T. This is a stream of T. The first that's given, and the second is a stream of T as well that I'll call stream odd. That's going to be the source of the odd ones. And what's its value going to be?
Stream of T.
Okay, yeah. So it's going to be a stream of T. That's true. As it turns out, it'll be able to deduce it through type inference. But okay. Okay. And what will its value be? Sorry? Yeah, stream even dot head. And then what? Sorry? Yeah, we could cons it directly. So I heard an idea, which we're going to build on a little bit later, where actually we could just, we don't have to do both of these here. Yeah, but absolutely, yeah, we'll be able to do it without having to list both. But in some ways, this is a clear one. Okay, so you have even and then odd. And then what do we have to have? A what? Oh, okay. Yeah, we have to cons it on to the call to the function. Alternating stream one. And what are we going to pass it as the argument? It's its argument. Yeah, we could do drop one, or we could do tail. I happen to like tails, but yeah, tail is kind of nice, but that's because of my list background. Okay. Oops. Okay. What did I? Oh, yeah. Didn't do that. Okay. Okay. So let's do alternating stream one dot, and we'll give it two streams, right? So let's do stream dot continually one and stream dot continually two. This is just a stream of ones. arbitrary length. This is a stream, I mean, of unbounded length. This is a stream of 2 of unbounded lengths. And then I'll take the first 10 and I will force them. And what should I get? 2, 1, 2, 1, 2. Okay. Conceptually straightforward. We have even, odd. There's a certain symmetry here, and we just do the tails for both and pass it on. Each of them is responsible for getting a pair of them, sort of dealing with 2 with them. They come in twos. Okay, great. Now let's try another way of doing this. So I'm going to say alternating stream 2. Now here I can't really say stream even because I'm actually going to do something a little bit more sly. I'm going to call it stream 1, stream 2, because which one is even, which one is odd is going to actually vary. And I'm going to say stream 1 here of head. And what could I do now?
Just call the function and first.
Yeah. So it's yeah, exactly. Precisely. Beautiful. What's going to be the first argument? Stream 2 is going to be the first argument. And the second argument is going to be, yeah, stream 2 is going to go here. And so that's going to be the next one queued up to have its head taken. And stream 1 will be the sort of one past here, who's going to be used only the next time. Yeah. So here's alternating stream 2. And just like we did this before with alternating stream 1, we could do it here. So here we've done something a little bit more clever. We've captured, in the state of the arguments, we've kind of captured which is the next one to draw on, which is the next one to have, to draw an element from, right? And we're just going back and forth. Just like that, right? It just goes back and forth, okay? Just like clockwork. It's like a flip-flop clock. Okay, great. So that's another way to do it. Now, there's a third way to do it, to which Iman referred to the key mechanism, for whose key mechanism Iman, to whose key mechanism Iman referred. English, that is the type of English up with which I will not put. Okay, so ladies and gentlemen, here we can actually do without a recursive call. We can use something that reflects the fact that we are garnishing, we are successively grabbing pairs of elements, okay? And when you think pairs, so there's a function in Scala to which Iman referred, whose job in life is to take 2 collections and applied to those 2 collections, it will actually produce a single collection of pairs. So crudely speaking, I mean, if I were to use sort of speak colloquial, given a sort of pair of, it's actually not a pair, but given 2 collections, you can then turn it into a collection of pairs. So it kind of commutes. There actually is a variant of this where you take a pair of streams or a pair of collections and it gives you a collection of pairs, which I find beautiful, and we'll probably examine that in just a moment, just so you can see the symmetry with it. But this is called, does anyone know what it's called?
No. What?
It is called, it begins with Z. It ends with P. It has an I in the middle. And it's not his. Okay. Okay, here. So it's stream1.zip, stream2. So this is going to create a stream of pairs. And getting that stream of pairs, we're going to be able to unpack them. Now, flat map. Flat map. Yes, flat map is going to be our hero in coming sessions. And its heroic status is going to start emerging right now. But we're going to do this a little bit more nicely. But in order for you to appreciate the niceness, you have to suffer the ugliness first. Okay? Okay, so this gives a stream of pairs, okay? What does, if I'm going to pass it if I'm going to call flat map, what does the function given to flat map have to take as an argument?
Pair.
A pair. It's going to take a pair, ladies and gentlemen. Watch this. We'll call it a pair. I could call it P for pair. Okay. Yeah. Just don't call it that pair. It's not a partridge in a pear tree. Okay. So P. And how do I get the pieces of P? Anyone remember? If it's just a pair, what can I do?
You can use A and B in the parentheses.
Ah, okay. Okay, we're coming there. We're coming. You're looking very far ahead, as you did with zip. But you can also do this: P dot underbar 1 or P dot underbar 2 for the second element of the pair. So what do we, if we get this pair, what are we going to produce? We're going to produce a what? A stream. Consisting of what? Consisting of what?
Both elements, string 1 and 2.
Okay, yeah, okay. And so the first element is P dot underbar 1, and the second element is P dot underbar 2, right? And do we have enough parens? Yeah, I think we do. Okay, so what is, if I had just done map here instead of flat map, what would I have gotten out? A stream of streams. It would have been a stream, each of whom elements consisted of a stream of 2 elements, right? I'm torn. You folks seem confident in your vision of that, but let me just show you. I'm going to call this stream bad. sorry, I didn't get quite enough sleep, and so I'm not very good with naming this morning. Okay, so why is this? Okay, it says type mismatch. Because it's, why is it giving a type mismatch? Yeah, its return type is no longer a stream of T. It's a stream of what? A stream of T's, right? Okay, now it could actually, I think, infer that. So, I mean, if we really want to persist on in a bad way, then we could see what we'll get out is actually a stream of T's. Do you see it? Here's a stream of T's. Do you see that? And it's not going to be nice. But you might not believe me on that. So I'm going to show you how not nice it is. Is that okay? Okay, hearing no objections, I will show you. Here it is. Look at that. What is it? It's just as Nell commented. It's a stream of streams. That isn't what we want. That's why it was called what? Bad. Why it was called bad. Okay? What we want is flat map. Why? What will flat map do here? Yeah, it'll stream them this nested. Do you remember we saw flat map for the very first time, I think? Perhaps you rue the day, but do you remember when we first saw it? We had option of 3, you know, sum of 3. We didn't want that. We wanted just sum of 3. You know, we don't want these nested structures. We want it all horizontal, sort of all imposed. So if we do a flat map here, and instead of calling stream 3 bad, we call stream 3, now we get these things. Do you see that? But ladies and gentlemen, there's yet a blemish in its eye. Okay? There's yet a blemish. This to me strikes me as lacking finesse and beauty. Okay? So what you can actually do here is there's actually 2 ways to remedy this, both of which are, in my view, acceptable. This is getting into sort of Scala aesthetics, but this is one way. I'm going to pass in a function. This is a function. This is not just a function, ladies and gentlemen. It's a closure. Give it the full dignity of recognition. It's a closure, right? Okay. Ladies and gentlemen, here we go. Another way to pass in a function is to do something like this. And pattern matching. So watch this. You might recoil from this initially, but then if you think about it, you'll recognize. If you think about it deeply enough and look at some examples, you'll recognize beauty. Case A comma B. Yeah, A and B. So this, ladies and gentlemen, destructures. Do you remember that with match and case statements, it actually calls unapply to sort of take apart what it's given. And so case is going to take apart what it's given, which is a pair, into 2 pieces. Remember that with matching? So in case expressions, so this is going to take apart a pair into its constituent pieces, A and B. And then it's just going to say A and B. So there we go. And now we have this, and it's just cleaner. Okay. So that's one way to do it. Now this next way, I think will work. I actually haven't done this, rehearsed this, but I think it's going to work. Do you want to see it?
Yeah.
Because it's another route to beauty. Would you like to see it? Okay. So no one protests seeing beauty. Okay, great. So ladies and gentlemen, here we go. Alternating stream 4. Are we ready? Okay. Watch this. Now I'm pretty sure this is what we do. Okay. Stream 1 dot stream 2 dot zipped. Oh, it's beauty. It's beauty statically, but its beauty carries over in a limited way to the dynamics. And I'm sorry to say to all those in the room that the beauty here will remain forever distant with infinite streams, because this is a computation that will never converge, which is unfortunate, because in terms of the code, actually it would function. If these streams were not of infinite length, it would work fine. But alas, the streams are of infinite length. Okay, let me just show you what I did with finite data structures. Here we go. We're going to have a vector of 1, 2, 3. This is going to be called val v1 or vec1. Here we go. And for vec2, we'll do 4, 5, 6. Okay. Are you ready? Are you ready to see the beauty?
Yeah.
Okay. 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 I'm glad you folks aren't burnt out of beauty. Okay, there we go. .zip. Now watch what this returns. Okay, and this is what got us in trouble. This is a little kludgy in Scala, but it's beautiful nonetheless. So ladies and gentlemen, this returns a tuple 2 zipped. Okay, which is basically this is a pair of collections, and this gives a collection of pairs. Okay. But it's not quite a full collection. And this is what got me. And now, if you go and you were to take each of these, you could just do A and B. This thing has a map method that takes in an argument that takes in 2 arguments. So map here, normally map takes how many arguments? 1. This map, if you apply it to a 2 zipped, it actually map will take in a function that takes 2 arguments. Okay, and here it will return a so we could say something like this. We could say vector of A and B, and then we could do flat map. Let's do flat map here. Here we go, flat map. And there you are. And it works with sublime beauty. So what's going on here? Well, normally map and flat map take a function that takes a single argument, right? Because it's applied to each element of the collection, right? Right? You have a collection of elements. Each element is a single thing, and you apply map to that, and the function you apply to map takes a single element, right? Or the same with flat map, it takes a single element, right? But this is a twist to that, which allows you to avoid that case thing, where if you take a pair and you do zipped on it, it returns a sort of special type of thing called a tuple 2 zipped, which regrettably is not truly a stream and therefore doesn't handle infinite streams well. But when you call flat map on that, flat map for tuple 2 zipped takes 2 arguments. Map takes 2 arguments. What are the arguments? They're each of the elements of the tuple of the pair. Okay, so it kind of defines map and flat map differently. Okay. Do you see what I'm saying? And the problem is, because this is not truly a stream that got returned from this when we applied it to streams, infinite streams, it ran into trouble because it was trying to iterate down the entire stream, and bad things happen. But we could do it with finite streams just fine. Do you see that? Okay, but that's a bit of a digression, but it provides an alternative to doing this case thing when you have finite collections. You don't have to do the case to destructured. Instead, you could turn them into a zipped tuple 2 zipped by doing this. This also has a degree of beauty compared to the old way in my eyes, because, ladies and gentlemen, here you don't do vec1 dot zip vec2, which kind of privileges vec1. I mean, if we look at this all, stream1 dot zip, stream2, here you have this nice beauty. Like, conceptually, you have a pair of collections, and you do zipped, and you get a collection of pairs. That's basically conceptually what's going on. And these are nice and symmetric. It just is the first item. You don't have to call zip on the first one, passing this as an argument. So I find it beautiful, even if dynamically it sometimes falls short.
And also you have both vectors has to be the same length.
Correct. Yes, I think that is correct. Yeah. Good point. Good point. Okay. Okay. Any questions of this before we go on to primes? collections before primes? Okay. Then if you won't object to it,